Okay, now, x squared minus 4x plus 3 times x squared minus 5x plus 6 equals 0 can happen only if this is 0 and this is 0, or this is 0. Now, of course, if this is 0, then it makes the whole thing 0. If this is 0, it makes the whole thing 0. And only for those numbers, because you can't multiply two non-zero numbers and get 0. Okay. Well, this, now, you all use the quadratic formula, which is fine. That's your general default. But it turns out this is easy to factor, and this is easy to factor, so I factor it, just to show that aspect of it, okay? And you got this, everybody got this. Got this solution set, but, okay, so x squared minus 4x plus 3 factors into x minus 3 times x minus 1. You can use the distributive law, multiply it out and verify it, and you should always do that if you factor. And I assume you know how to factor. I'm not going to teach a lot of factoring in this course, but if you need it for your course, then we'll address it. And maybe actually in this course we should. I don't do it in the pre-calculus course. I assume people know it. But we probably should spend a session on factoring, okay? Because it's going to be less important in my course than it might be in your course. Okay, anyhow, this factors into x minus 3 times x minus 2 equals 0. And you should understand that much factoring, okay? And then, of course, x minus, okay, if this is equal to 0, then x minus 3 times x minus 1 is 0. And that happens if this x minus 3 is 0 or x minus 1 equals 0, right? So that happens if x equals 3 or x equals 1. Okay, then same thing here. This factors into x minus 3 times x minus 2 equals 0, which is so if and only if x minus 3 is 0 or x minus 2 is 0. So we've got all these ors here, leading us to x equals 3 or x equals 1 or x equals 3 or x equals 2. Now 3 is repeated. I didn't write that down as I did here, but I wanted to give you that language because that's going to be important. But the solution set then is just 1, 2, 3. Okay, on this one, okay, we write it down. Now I've told you, I want you to write down the step where we say, okay, x minus 2 is 0, or x squared plus x plus 4 equals 0, or x minus 5 equals 0, or x squared plus x minus 6 equals 0. Okay? Now this tells you that, okay, well this solves very easily, x equals 2, or x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times 4 over 2, okay? Or x equals 5, or, and I'm going to do this one by factoring. This one factors into x plus 3 times x minus 2 equals 0, okay? And it could have used a quadratic formula here. I'm not being picky about that right now, but you should know, again, how to factor this. Okay, these are pretty easy factoring. So you might want to review that a little bit if you don't know. So x equals 2. Or you get, well, you get that square root of negative 15 up here. Both of you got it. Okay, that wasn't a problem. And then this one comes down to x plus 3 equals 0 or x minus 2 equals 0. So you get x equals 2. Or no real solution here, okay? So you're not going to have anything to add to your solution set. So there we have all the possible alternatives. X equals 2 is repeated. So it goes into the set, but only once. In the order they come out here, 2, negative 3, 5. You usually list them from least to greatest because it's easier to look at. Okay? Make sense? Okay, so that's not too bad, right? Okay, well, I could ask you, and I think I will, for homework, to see if you can do it, to expand this expression and this expression. You know, just multiply it all out into powers of x. No parentheses, okay? I want to see if you can do that, and if you can't, then and you might not be able to. If it turns out that you can't do that using the distributive law, then we need to work it through, okay? And give you a little more practice and break it down. But you're all pretty good with the distributive law, so I'm kind of thinking you have a pretty good shot at being able to do that, okay? Now, if you work on it for 15 minutes and you aren't getting anywhere, you can kind of stop at that point and show me what you've got, okay? And I can kind of see what it is that's troubling you about that. It might take you, 20 or 30 minutes to do it if you do it carefully. Even then, it's going to be kind of vulnerable to clerical errors. You might not get it all right, but I want to see at least the right process, okay? Okay. Now, minus 4x plus 3. Okay, this is the first expression where you got the solutions 1, 2, 3. Okay? If this is a function now, we can talk about the graph of the function. So what points can you easily find on the graph of this function? Like, what's a really easy number to plug in for x? Again?
0.
Yeah, 0. Okay? Okay, easy point. F of 0 is 18. Plug in 0, you get 18 because both of these are 0, both of these are 0. So this one's just 3, this one's just 6, and 3 times 6 is 18. So we have the point 0, 18, which lies on the graph. Okay? Okay, then there are other numbers that you can plug in here and get 0. Can you give me one of them? Or, 1 should give you 0. Why? Now 1's easy to plug in. Even if it doesn't give you 0, it'd be easy to find a point when x equals 1, right? But we know it's going to be 0. How do we know that? Because we solved the equation, this times this equals 0, and we got 1 as one of our solutions. Okay? So, So these are the zeros. Of our function. Okay? So we can say, okay, well, if x equals 1, x equals 2, x equals 3, well, those are the points 1, 0, 2, 0, 3, 0. They have to be on the graph. Okay? These are the only solutions of f of x equals 0. So the graph touches the x-axis only at these points. Okay? Because the only way this can be 0 is if this is 0 or this is 0. The only way this can be 0 is if x is 1 or 2. The only way this can be 0 is if x is either 2 or 3. Okay? And actually that should be 1 or 3. This is only 0 if x is 1 or 3. This is only 0 if x is 2 or 3. Okay? So what I want you to do is sketch the graph of a function that goes through just these 3 points. Now you're not going to be likely to come up with the correct graph. You're likely to come up with a graph that has some contradictions, but we'll see what they are, and it's not hard to sort them out. Okay? There are things you don't know yet. So there's a couple of things you need to know to do, but let me at least have you draw a graph through those points.